Okay, we've covered a lot in this chapter so far. It's time to do some practice. So you've learned how to create recommender models with not only user item rating triples, but also with user features and item features. We're going to use a real data set based on donorschoose.org. They entered a competition on Kaggle where they shared data about donors who come to their website to give money to school projects. So if a teacher needs instruments or science project materials or anything else, they can describe their needs on this website and explain exactly what they're looking for, whether it's money or items or resources, and people can come make donations. Now, to be successful, obviously Donors Choose wants to get more donations, which means they wanted to create a good recommender model to encourage donations. So we are going to use their data, or actually just a subset, because that was a massive amount of data. I've filtered down a subset of their data just for one particular state. And that data is available right here if you want to use the CSV file. I'm not going to share the info here for the SQL Server where the exact same data is stored, but those of you who are taking my class have access to this book and can do that there. So let's go to Azure Studio, create a new experiment, and let's actually begin by pulling in those CSV files, or again, if you're one of my students, you can load the data directly from SQL Server. So let's come down here to Data Sets, New. I'm going to assume you've downloaded the data, and we're going to start uploading these files. So we'll find these. Here we go. Here's the reduced files. Let me grab donations and just go through each of these and upload them one at a time. As you can see, we have a lot of data. They basically took their normalized database, exported it, anonymized the donor info and the teacher details, well, at least the identifying information, and then shared it just how it was right here. So we've got a variety of data sets. We've got the donations, which is going to be like an association table between projects and donors. So it's going to have a donor ID, a project ID, and then an amount donated. But then we also have, for the projects, various details like the resources requested, the school the project is for, and the teacher the project is for. So a project can have many resources, but a project is for only one school and for one teacher. So we have a couple of one-to-one relationships and then a one-to-many here, which will have implications for what we do later. So I'm going to clear these out. Go back to my experiments. Oh, yeah, I lost it. Got to make a new one again. Blank experiment. All right. We'll call this donorschoose.org. Okay, so let's start with the basic user item rating triple. And to do that, we'll need the donations data. Go ahead and take a look at that. Okay, project ID, donation ID, donor ID. There's more than we need in here. So we've got information here like donation included, optional donation, donation amount, card sequence, date. All right, so let's grab a select columns to reduce this down to just the user item rating triple. We can use those other features later. All right, so out of here I need the user is what, and the item is what. Well, in this case, the donor is the user, and the project is the item. Now, what is their rating? Well, we've got a variety of things we can use. Donation amount, whether or not it included an optional donation. Both of those are good options. So for now, let's just use donation amount. This will give us a lot of options to make adjustments. So let me check that box, run this. And remember that Azure Matchbox Recommender is expecting those features in that exact order, user item rating. So let's see what order they come out in. Remember, the order we select them in is not necessarily the order it'll be in. It'll be in the order that it comes from the original data set. So user item rating means we need to get it into donor first, project second, then donation amount. Okay, no problem. All we have to do here is come to select columns, launch that selector again, and go to with rules and check the allow duplicates and preserve column order. And now we've got it in the right order, donor, project, amount. It will stay in that order when we run it now, and we should be good. All right, so the next step is we need to get the donation amount in an acceptable format for Azure. So let's make sure, first of all, okay, it's in the right order here. Let's click on the donation amount table and notice that we've got a min of 18 cents and a max of 10,387 and 1 cent. Well, Azure prefers ratings to be between 0 and 100 in integer format. So let's work on making that happen. There's a formula for scaling that we can use, and the formula is the actual value minus the min divided by the max minus the min times whatever we want the scale to be set to. And we want it from 0 to 100, so we'll say times 100. So let's do that. We're going to have to break this down into a few steps. Let's grab an apply math operation pill. And let's begin with that first part of the equation. We're going to operations. We're going to simply take donation amount and subtract the minimum value. What was the minimum value again? It was 18 cents. Now I wish there were a way to automate rather than have to type in a constant like that. There might be, I just haven't found it yet in Azure. That's okay, we'll work with this. Launch column selector, we want to do this on donation amount. Perfect, that's the one. Output mode, we don't want result only. That will only give us the modified donation amount. We need the other columns as well, so we're going to use in place. So let's go ahead and run that. Also, it appears that I can only do one operation at a time. Otherwise, I would do the whole thing right there, and that filled. Anyway, these values right here should be 18 cents less than they were above. Sure enough, this one was a $15 donation originally. Now it's $14.82. Great. Let's copy this. Control-C, Control-V. And now let's do the next step of the operation. Now we need to divide that number by the max minus the min. Now that's not from this modified version, it's from the original data. So let's pull out a calculator and simply do that by hand. So click on donation amount, pulling out my calculator now. Okay, max is 10,387.01 minus 0.18 for 18 cents. Okay, that means right here we're going to be dividing donation amount by 10,386 and 83 cents. And then let's make sure we change subtract to divide. Then go ahead and run it. So this is going to give us a bunch of very small numbers between 0 and 1. So let's visualize this here because of that formula. So these numbers are super small. We want the scale to be not between 0 and 1 because Azure Recommender doesn't like floats, it wants integers. So we're going to multiply with another math operation pill that value by 100. Multiply 100. All right, let's take a look at the output. So notice that we still have these really small donation amounts. Even after multiplying by 100, we've scaled it down, and most of them aren't even close to 1. In fact, if we were to round this, most of them would end up being 0. Why is that? Well, it's because the data are incredibly skewed. Let me show you what I mean. So take a look at this select columns right here, and donation amount. This is a histogram. It looks like a single bar. Well, that's because, here's a better view of it. That's because most donations are only between $0 and $100. However, our max is 10,000, but there's only one of those or very few of those. So how do we get a much smoother donation amount to use as our rating? Well, one thing we could do, that's a positively skewed feature. You might remember from the data preparation phase, we can use an apply math operation to run a natural log transformation. I'm going to do that right up here. Copy and paste this one. We're going to add one more pill, and before we do everything we just did, let's first apply this natural log. So, alright, there we go, that looks better. Let's change operations here to basic natural log. Now I don't need ln plus 1 because I don't have any zeros. People don't donate $0. It's going to be positive, so I won't have any errors. Again, do this in place, but what this is going to do is it's going to change our min and max values. So let's run this first and get those one more time. Okay, let's visualize here. So donation amount. Now our min and max, we've got a negative. I'm going to copy these down. And I'm going to put them right here on the pill to make it easier to keep track of it for us. Okay, so for this one we're subtracting the min. Let's change this to subtract negative 1.7148, and then on the next pill we need the difference between those, so I have to use my calculator for that. So it's 92483 plus, which is minus 1.7148, gives us a range of 10.9631. Okay, got those updated. Let's go all the way down here through the end now. So as you can see, there's quite a bit of data wrangling or feature engineering required sometimes just to get a rating of some type that works for us. That's okay, this is pretty normal. So essentially what we've done now is we've created a rating that has a much more normal distribution to it. Let's take a look at here at donation amounts. See how that histogram looks so much better? Okay, but it's not done yet. Take a look here. So click on donation amount. Notice our min is 0, our max is 100.0001. That's just outside the acceptable range. Since we start at 0, this is actually going 101.0001. So what we need to do, oh, and one other thing is, notice this, we need to have integers, not floats. So let's do a couple things. First of all, rather than multiply by 100, multiply by 99. Let's run that again. And then we're going to add one more apply math operation pill to round the digits. So let's first just take a quick look at this and make sure it looks right. Alright, beautiful. Now we're at 99.0001. That last little bit that's over, that's fine. It'll be okay. Alright, so with that working, let's copy paste another apply math operation. Connect the dots. And here we go. Rounding is what we want. And you probably didn't realize that there were 12 different rounding options, but we're going to use round digits, which will get rid of that extra 0.0001 for us. And then constant precision is going to be at 0, so there's no decimal places. Let's go ahead and run that. Where did my mouse go? There it is. All right. Now let's take a look. Okay, beautiful. And it's 0 to 99. Perfect. That's what we need. So now we're okay to go ahead and split the data and do everything else. Let's put all the rest of these pills in here. split data, we're going to use a recommender split. Let's use a random seed so you get the same answers as me. Just search for a matchbox and we'll get the score. Oops, well, we need the train first, then the score, and then I should search for recommender. Then that would have given me evaluate as well. There we go. All right, let's connect these the right way. Split data goes right there. Train matchbox goes right there. Right side of split data down here. And how do I know this? Again, hover over these little input pills. It tells you data set to score. Same as our testing data set. That's this one. It says trained recommender. Okay, from right here. This one says training data set. That's going to be the left side. And then down here on evaluate recommender, this is where the score data set goes. This side, test data set, that comes from the right side of split data. All right, I'm going to move that over just a little bit. Well, that's fine. Let's go ahead and run this to the end. I've left score on, let's change it to rating prediction. And in the book, while that's coming up, you'll notice that there are a variety of tables included where I've summarized all of these, let me pull this up here, all of these scores that we should have. So if you're following along with me and doing everything properly, you should be able to see and compare and make sure that you've got these same scores that are in the book. So let's flip back here. All right, what did I do wrong here? Oh, good. I'm glad this came up. I wanted to show you the error, and then let's add the pill to fix it. It says more than one rating for user 51, big long thing, and item this. What does that mean? Well, it means that a donor donated to the same project more than once. That's to be hoped for, expected, right? We like it when that happens, but a recommender can't handle that. So what should we do? Well, how about we combine all of the donations for a particular donor to a particular project into one record and just sum them up? Well, that's a perfect application of the apply SQL transformation pill. What I want to do is before we ever apply a math transformation, we're going to stick this right here. We're going to feed that into the left side, apply SQL down to apply math. All right, we're going to use SQL, since we learned that earlier in this course, to generate a sum of all the donation amounts. So what we want is donor ID, project ID, and then the sum of donation amount from T1, but now we've got to remember to group by. And in a group by clause, we have to put everything that's in the select except for those things with aggregate functions around them, project IDs, so we don't put donation amount there. And that should take care of it. It'll create a new column called sum donation amount. You know, I don't want to have to go through and change donation amount, the name of it, to all these, because it'll create it as this name. So I'm going to go right here and say as donation amount. So it'll overwrite that existing column as a sum now. Now, there's an implication of this. Let me show you. I'm just going to run this pill only. The implication is what? Well, our min and our max are going to change once again. So actually, I should have run this pill too here. We're going to have to edit the appropriate pills. So I'm going to run this one and let's see what our new values are. Okay, right click. All right, donation amount. Okay, that doesn't look quite right. That's the same as our previous ones. Let's see here. Sum donation amount. Okay, the new min is correct, but this new max is different. That's okay. Then we do this apply math operation, and we're doing this in place of donation amount. This should have 93548, is that right? Oh, Sorry, I'm not paying attention. It did change. 93548 right there. Okay, so let's adjust these. This one, the minimum didn't change because again, all we did was add donation amounts together. We didn't reduce the value of the lowest donation amount, so that min remains the same. However, the difference between these, I'm going to pull out my calculator for this one. Let's do a 9.3548 minus or plus 1.7148. Okay, gives us a slightly larger range. So down here, we're going to leave that one alone because the min didn't change. On this one, we're going to change it to 11.0696. Okay, applying this to donation amount, that's correct. We're going to round or multiply by 99 again, round it. That should all be happy. Let's go ahead and run this to the end now. Okay, looks like everything finished and is happy. So let's take a look at our rating prediction here. Okay, so this MAE says that on average, our donation amount is off by 8.11803. Now, that's actually a pretty big number because remember, this has been natural log transformed. But that's okay. It's definitely better than nothing here and a decent start. So let's check these numbers against my table in the book. There it is. Yep. Okay, so if you got those numbers, you're on the right track. So take a moment now to go through and you can just test the item recommendation from rated items. So to do that, click on Score Recommender, change rating prediction to item recommendation. But we're leaving this on from rated items only, which is for model evaluation, which means that we're only predicting projects to donors that they've already donated to. And the only reason we're doing that is so that we can check for model fit and see how accurate our predictions are. So I'm not going to do that here in the video, but go ahead and go through, pause it if you'd like, and check all of these and make sure you're getting all of these same numbers. Okay, so let's see. I mean, look, that took, what was it, 1, 2, 3, 4, 5, 6 pills just to get the data in the right format. This is not uncommon when doing these recommenders. It takes some time to get that data the way we want. But what I want to do is have you also just test and learn how some of these different prediction kinds work. So back here in the book, I've got a way that you can sort of quiz yourself here with some word problems. A potential donor is visiting the website but is not logged in, therefore they're not identified. They're browsing school projects and click on the details of a particular project. What are the 5 most recommended projects for those looking at or interested in this particular project ID right here? Generate a recommendation that looks projects that look most like this project regardless of whether those projects have received donations from the same people who donated to this project. All right, so what does that all mean? So first of all, what do we know? What are the inputs? Do we know who the donor is? No, they're not logged into the website, so we can't identify them. Do we know what projects they're interested in? Yes, they're currently looking at this project right here. So what type of recommendation is this? Well, it's an it is a related items recommendation. This is the one we use when we know a particular item of interest, but we don't know who the user is. Now, the next question though is, do we do it from all items or from unrated items? Well, it says that generate a recommendation of all other projects that are most like this project, regardless of whether those projects have received donations from the same people who have donated to this project. That means that we're going to do this from all items, not only projects that have never been donated to by people who donated to this project right here. Okay, so this is just testing to see if we understand what prediction kind and item selection are referring to. So let's run that. Usually the train matchbox recommender is what takes the longest time. The score and the evaluate are typically much quicker. If yours was like mine, this one actually took like, I don't know, 2 or 3 minutes to run, which is not uncommon. In our next example, we might reduce the amount of data we're looking at just so that it doesn't take so long to run. For now, this shouldn't take too long. I guess yours is running too, so I won't worry about leaving the video recording. There we go. All right, so I'm going to look at, now notice, evaluate recommender is going to break. That's normal. Why? Because it can't evaluate recommendations that don't have any data. So when we suggest related items from all items, that means that there's going to be some recommended items that have never been donated to by a particular donor, and there's no way to evaluate. But that's okay. We don't need to evaluate because we already did back when we had this set to from rated items only for model evaluation. That's where we got the NDCG scores that we checked against the table, or I'm assuming you did. And it doesn't matter. So anytime we change this to, we call this one of the deployment methods. We're either going to deploy from all items or from unrated items. As soon as you change it to one of those, we know that evaluate recommender is going to break, and we don't care. We just leave it there. So for now, just take a look at this. And I believe what I put there was the very first one in your list, 4cc. Yep, 4cc. So what we're referring to are these 5, these are project IDs right here. For other projects that people who donated to this most commonly also donated to, or people who donate to other projects in this one would likely want to donate to these. So anyway, that's what we're referring to here on deploy model. Let's try another one. And so if you're not sure on any of these, the feedback, this says here's what we're looking for to make that work. All right, let's do the next one. A potential donor has logged into the website to donate to a project for their child's class. After logging in, the user is directed to the home page. Okay, so already we know. What do we know? We know the user ID. And if we know their user ID, then we know that there are 2 types of score recommenders that take a user ID as an input, an item recommendation and a related users. Okay, so we're probably interested in one of those. This next sentence here says that after logging in, the user, we want to generate a list of 3 projects. So what is it we want to recommend? The input's a user ID, but we're not recommending other users to them, we're recommending items. So that means we're going to want an item recommender. All right, what are the 3 most recommended projects for this particular donor that this donor has never donated to in the past? Okay, there's everything we need to know. So let's head back here, close this out, change score recommender. Right here, an item recommendation from the book. We know that this is the type that takes a user ID and recommends items back. And we want to recommend only unrated items. So it specifically said right here that this donor has never donated to in the past. Okay, that looks right. I'm just going to run this pill only, not even bother letting the evaluate recommender break. Oh, let's see what we did wrong here. Training data is null or empty. Okay, great. I'm going to leave this one in here. In the book, you might remember that whenever we do a recommendation from unrated items only, there's one more input we have to connect right here. Training data. Training data comes from the left side of split data. The reason why it needs this is it can't make a recommendation for only unrated items, because that means unless it has the entire data set. So before we had the testing data or data set to score as an input, but it can't recommend from all unrated items unless it has the other side of split data too, unless it has this entire data set to choose from. So that's all. We just had to give it the complete data set to recommend from among all unrated items. And now it should be happy. Yeah, we have a lot of data, so the scoring takes a while. When we add user features, we remember to come back here and include a partition and sample pill to turn this data down. Make it go a bit faster. All right, that was taking way too long. Too many combinations of projects and users for the processing power of this free tier of Azure ML Studio to work. So What we're going to use is a nice partition and sample pill. This is as good a time as any to let you see why we might use these and when. When we're in development stages of our data mining projects, we can use a smaller sample of the data. So stick this partition and sample pill right in here after the data import and the select columns. And let's turn this thing down to 5% and use a random seed of 1, 2, 3, 4, 5. And let's go ahead and run this thing one more time. Okay, much better, less than a minute compared to over an hour that I was waiting on that before. So let's go back to our question, which was right here. What are the three most recommended projects for this donor, 609? All right, let's take a look here. It's probably the first one on the list. Yep, 609. We're just going to give them these three right here. Now notice it looks like the same for these three are the same for most of them. That's because we turned the data down so much that there were very few options. But if you scroll down far enough, you'll find that there are some differences, often in the 4th and 5th records, like right here, right here. Oh, even there in the 3rd one, it's something a little bit different. Anyway, but that'll do. This last one, I'm going to let you take a look at on your own. One more of these potential donor right here. Don't refer to in the last question. You know, I'm gonna skip that one and move on. Let's call this good. We've got our complete user item rating triple ready, and we'll stop this video and then proceed with adding user and then item features in the next two.